And that also allows me to relate to the last one of the last presentations of Mr. Moser, who highlighted some additional pre-treatment or after treatment options, and for instance screening. So if you look at ash removal, then of course first it depends on the nature of your feedstock, what to do, what is the best procedure. And if you have a lot of sand with your feedstock, or stones or things like that, then of course the first step could be a screening. And also integrated in the washing, you could try to get rid of these, let's say, macro ash constituents. When it comes, apart from that, when it comes to ash removal, then the washing does not really contribute to the, let's say, inherent ash, so the ash inside the biomass, and not other than, let's say, removing some problematic compounds, like I explained, the potassium and chlorine. So it may very well be that the overall ash content is still relatively high, but that may not be problematic in conversion processes. So I don't know whether that answered that question, and whether someone would like to react on that. If not, then Victor, will you take a second one?
Sure. I think there were several other questions in the chat room before this one, but or we can move on to the ones here. But maybe before we move on to the three questions I see here in the chat room, in the breakout room, I just wrote down one, I think, which was quite general, but from before, but I think we can cover if it hasn't been considered before already. So I think we had, so these two questions are kind of, I think they coincide, they go together. So one was, what are the main agricultural residues in mind? And the other one I think goes well together with this one. It says agricultural residues are disadvantaged, as the speaker explained. Local production for local consumption or on the spot utilization should be encouraged in terms of total energy balance. How do you consider this point? So I will attempt to address this. I think as far as one of the challenges with agricultural residues, I think everyone has already said, mentioned this, is that the bulk density is the handling that's required before and after, mainly before maybe because of its bulk density and its bulkiness. I would say that in my mind, there's no real answer to what's the only or best agricultural residue that should be used or can be used. It's quite local, and whatever's locally sourced and locally available should be considered and the adequate technology chosen for it, mainly probably to reduce handling costs, to be more efficient. That's from my side. What about you? Yeah, what do you think?
Yes, I agree. I'm also thinking of this last question. There is, what about the sourcing of agricultural residues, and is there already a market for it or not? Indeed, agricultural residues is a very wide term. That was also one of the questions in the main chat. What are agricultural residues? What are the main ones? Well, you could say it's crop residues, agricultural crop residues. It's from the residues from cattle, but it's also residues from food and feed processing. So it's a very wide range. And so it's difficult to say things in general. But when you look at the utilization of residues, agricultural residues at the moment, then it's not that, for some of them there is already a market. Straw is a good example, of course. And for instance, in the Netherlands, there is no surplus straw available for energy purposes. It's all used for cattle beddings and the like. So for some of them, there is a market already, but I think in general, this low density and the distributed nature of the distributed origin are large bottlenecks. So in that sense, in many cases, there is really a need for a densification process like torrefaction. It could also be pyrolysis in other ways, but torrefaction surely is a strong candidate to densify the material and to make transportation much easier. And clearly, you have to process the material locally as much as possible. So in general, that means on a local basis, you have relatively small upgrading plants. You upgrade it to a, let's say, to a bioenergy carrier, for instance, by the means of torrefaction. And then transport is less of a hurdle. And so you can transport it over larger distances, and it can become more of a commodity.
Okay, my point was that I'm from the DBFZ in Germany, and we are analyzing the market opportunities for bioenergy carriers in Europe. And I spoke to some stakeholders in Germany, and they told me actually they don't need this torrefaction here in Germany because they have other products, and also there is so much other users. They have interest in the same feedstocks. So there is not even a possibility to get enough volumes of feedstocks for torrefaction. That was my point.
Mm-hmm. Well, that can very well be. As said, it depends on the feedstock. And as said, for instance, for straw, that is the case in the Netherlands as well. So also there, we don't need torrefaction. But for instance, when you look at large sectors internationally, then you can also think of the sugarcane industry, the palm oil industry. There, in these type of industries, there are very large amounts of residues which cannot be utilized locally. So for those cases, torrefaction could very well be an outcome to make that, let's say, to disclose those streams for a larger market.
Yes, if I may add also is that because biomass is such a broad term, even in agricultural residues, maybe there's competition for straw-like biomass, straw residues of different crops, but biomass could be, I mean, torrefaction fuel or feedstock could be municipal waste. It could be many other things as well, waste from food processing industries that might not go to a reactor or gasification or a biogas facility. So I think that overall, anything that probably can be used as a food supplement or as a competing industry that could utilize it, then that probably is used up in Europe or in Western Europe at least. It's definitely not the case in Eastern Europe or Central Europe and other parts of the world, I'd say. But I think there's definitely, because there's such a wide variety of residues out there, and that the competition should not be a problem, but it always going back to what's available locally and what's the best application for it. So I think that really sums it up, I think. But there's no clear answer, I'd say, to this.
Yeah, we also experienced from our conversations with stakeholders in different parts of Europe that it is very, very different, in the southern part of Europe and in Northern Europe. And so we have to analyze this very much in detail, to find the right market.
Yeah,
Indeed. But I think that's also why I mentioned that as a starting point. I would say the starting point is that there is an increasing pressure on using forestry biomass for energy purposes. So there is a pressure to route that more to fuels, but even more to chemicals and materials. And on the other hand, when you look at the total resources available, then there are enormous amount of agricultural residues that is available or could be made available if you look at that worldwide. And those residues are still not utilized, and I think to a large degree that is due to the fact that they are difficult. They have these difficult properties like a low density and are very difficult to handle. And so there clearly torrefaction could be one of the technologies that helps out. But I would say there was also another interesting question about, well, what about pre-extraction? Torrefaction, of course, destroys to a large extent the structure of the material. Could you apply pre-extraction to extract valuable compounds from certain residues before doing the torrefaction? And hemicellulose was mentioned. Well, I would say that in general, clearly this is true, that pre-extraction might be an attractive option. For instance, if you look at different nut shells or nuts in the food industry, their oil might be extracted first, and then you could use the remaining part and do a torrefaction process to upgrade it. In general, I would say to extract the hemicellulose is perhaps not the way. Actually, in torrefaction, hemicellulose is extracted preferentially, or is devolatilized preferentially. So that already happens in torrefaction. You might adapt the torrefaction process to focus on that and to look at doing the torrefaction in such a way that you can further process the gas and extract valuable compounds from that. That might be an option. So there are options, and that could further contribute to adding value to the biomass, and so creating more attractive business cases.
So yeah, so if I might add to that, I think that maybe, in my opinion at least, torrefaction or carbonization should be something towards the end of the life cycle of that feedstock or residue, I think. So if we look at the cascading use of wood, if we refer to that, the forestry sector, we could apply that to the agricultural residues as well. So if you can extract everything you can from those residues, from that biomass, and then towards the end, either leave it for energy use, for combustion, or you turn into torrefied pellets or torrefy it, or do carbonization, I think would be maybe the best approach, instead of just burning it in the open.
Yeah. I see there is also a question about what kind of considerations need to be taken when choosing feedstock to produce biofertilizers or biocarbon for agricultural residues or agricultural use, I must say. Yeah, of course, that's a totally different field. We focused primarily on using agricultural residues for energy purposes. Clearly, there is also quite some potential to produce biochar, and then use that indeed, well, as a for soil beneficiation, and by combining it with other materials, it could also be used as a biofertilizer. What kind of requirements there are then, that would require a totally different webinar, I think. That's a field that is still quite under development. it is certainly not true that every biochar you make will be suitable for that application. You certainly have to meet strict requirements, and of course, then you need also an intensive test program with the specific soil and the specific agriculture and the specific plants you would like to farm there. So that's quite a trajectory, but certainly there is quite some potential there as well. Victor, do you want to add something on that?
No, I absolutely agree with you. I mean, biofertilizers or fertilizer based on biochars or carbonized biomass and torrefied biomass, it's I think, as you said, it's still, there's a lot of experimenting going on. There's a lot of trials, and it all depends on the soil, the quality of the soil, what's missing, what needs to be added, depends on the feedstock that you need. There's really, like you said, yeah, what works in one place might not work, or most likely will not work in a different place. And so it's quite complex, and I'd say it definitely requires another webinar for than apart from this one. Yeah, maybe that's a good idea for Christina and IBTC for
Indeed.
the next webinar.
Yeah, it would be an interesting topic.
I just moved into this room now and did hear just that you say this is a good topic for us, but didn't hear the contents. What should we organize as a next webinar? Can you repeat, please?
It was about biochar.
Okay.
So as for soil remediation and or soil improvement,
Okay.
or for other purposes.
And
of course, torrefaction or heat thermal treatment in general can play a role, or is a good means to produce biochar as well. But I said, not all biochar is the same, and it is very dependent on the applications, what type of requirements there are for the biochar. But this might be an interesting topic for a separate webinar. That's what we said.
Yeah, we'll pick this up, and I keep this in mind. However, we had already once a webinar, joint webinar with International Biochar Initiative, and we did foresee to repeat this. So all the audience and all the parties interested, please keep an eye on what's going on with IPTC, and you will find sooner or later a webinar or another event on biochar and fertilizer materials as well.
Yeah. Because we said this is a field that is quite, there are quite some developments here. It's moving rapidly, and so indeed it might justify another webinar on this topic.
Absolutely. I think, Michael, there's a question that arrived. I think it was part of your presentation, but maybe you can also cover it now. So if I read it for you, it's: for agricultural feedstocks within Europe, in your view, what are typical volumes of biomass to be fed to a torrefaction or pyrolysis plant, and typical storage times of biomass at site before being transported or processed? So the conversion rates, I guess, I think you had that in your presentation.
I mean, basically, I see that the processes that are continuous processes are all designed in a way that you feed in approximately 8 tons an hour. Or sorry, you produce about 8 tons an hour. Now, depending on the degree of carbonization, you would feed in between 20 to 30 tons an hour of material, which, as especially Wolfgang Moser highlighted, may find its limit because of the low bulk density in some of the agricultural biomasses. By this, you will reduce the capacity of the reactor, which might be designed on wood basis. So, but that is approximately what you would need on feedstock per year, somewhere between 100 and 150, maybe up to 200,000 tons a year feedstock. Now, when it comes to storing this, I mean, agricultural biomass, unfortunately, or fortunately, I don't know how to say it, but fact is, it's mostly a seasonal product. So you're not producing all year round, but you have maybe 2, 3, maximum 6 months of production of this agricultural biomass, meaning the rest of the year it need to be stored, meaning the rest of the year it need to be protected against first of all, the rain or snow and ice. It need to be protected against all the impurities that may come in from carried by wind or thunderstorms. And if it is only sand and soil, which creates a problem, let alone all the Coca-Cola cans and so not that what all the cans of sodas or other impurities you need to protect. And actually storing biomass usually is a process that leaves you on the losing end. So you will have always less biomass you get out of your store than you put in, because of the natural fermentation of product. So all of these need to be calculated into a business model. The capital bound in the store, in the stockpile of the biomass, you need the right storage area. Most likely you will need some hardened floor at least to get rid of the water. You will need large tarpaulins to protect the material against the water. And all of these has a certain influence on the business case and on the design of the size of the individual processing plant and the supply chain. Usually, I mean, especially with agricultural biomass, I think the tendency is to go rather to smaller units and multiple units and place them where the biomass is, instead of increasing the size of the processing plant to a couple of 100,000 tons, and then run into issues with the storage area, which you would need to store for half a year of production, the feedstock. I hope that answers the question sufficiently.
Yeah, perhaps, Michael, I may add to that. One of the solutions could be that you have let's say, a multifunctional plant where you are able to treat different types of agricultural biomass that are harvested or collected at different periods in the year. In theory, that could be possible. Whether in practice that is really possible, I think some further work is needed there. And of course, it totally depends on the specific agricultural residues you consider. But that could be one of the options to overcome this seasonality issue. In addition to what I showed in my presentation, for instance, for roadside grass, that you could consider silage. So in that sense, store the roadside grass, but in a way that it does not deteriorate during storage. Those are options. And again, it totally depends on the type of agricultural residues, how to deal with that. And of course also the location. If you are in, let's say, more hot climates, and you are able to have more harvests per year, then this seasonality also becomes less problematic. Yeah.
An alternative solution maybe, and this I think was addressed also by Wolfgang Moser, that you introduce an interim step of producing, for instance, pellets or briquettes, so a kind of a pre-densification, meaning that you do this on a very low quality scale, not really spending too much money on this densification, but by these allowing an easier and cheaper storage during the season. And on the other hand, a more homogeneous input or inflow into the carbonization part, which will increase the capacity of decarbonization. So there are alternative pathways, and I think they need to be evaluated on a case-by-case basis. I know also that our technology suppliers in the IPDC are relatively flexible, and with certain adjustments of the settings, they might change from agricultural biomass or agricultural feedstock to woody feedstock in certain seasons. It's just a question how the densification then would need to be adjusted, and if eventually some additives or binders or some coating need to be implemented here.
Yeah, thank you, Michael. Are there people in the audience who would like to contribute to this discussion or bring forward another question?
I just wrote in another question regarding in our project, there is a big steel producer investing in torrefied biomass use in their plants. And I was always wondering, they are trying to use mainly waste wood, but in case they don't have enough waste wood or other, they will look for other sources. And did anybody do an estimation? Do you know something about it? How much feedstocks are available in Europe for something like this? Or is there enough feedstock available for such activities?
Yeah, this is quite an issue. I think in general, most of the steel industry, the different steel industries, at least in Europe, they are looking at this option to replace coal by torrefied or carbonated biomass, and clearly this requires huge quantities. So whether in principle in Europe there might be enough, but Europe is large, so then still you have to address the question of logistics, and also an important issue is that you cannot cover one steel plant from one torrefaction unit. So you need a whole range of torrefaction plants to provide enough material for one steel factory. So also in terms of market introduction of this technology, that is quite an issue. Actually, we had the same issue with the pulverized coal power plants in the past, because they said, well, torrefied biomass might be fine, but we would like to have competition in the supply of this material. So we not only need to have sufficient torrefaction plants to meet our demand, but there should be more than that, because there should be competition to avoid to get a good market situation where a stable price will be established. Well, this issue is also there in the steel industry, and well, I think it's under development at the moment how that will go.
I think so. I think it's also market driven. So if it's feasible, it will be done. So if demand grows, supply will grow, and whoever pays the most will be supply. So it's all the energy intensive industries. It's not only the steel, it's the cement factories and so on. So in the end, I think it's gonna end up just like we had with the white pellet or the wood pellet industry. In the beginning, it was small use, and now we have big power plants using it. And of course, once the demand grows, I think all these feedstocks will have to be imported, Europe or otherwise. But in the end, I think it's only market driven. I don't know if are there any other questions or any other topics someone would like to suggest maybe we should discuss. It is quite late maybe for some, and people are looking forward to maybe ending the day on a high note. So who should we ask for help? the World Bioenergy Association. Maybe he can chime in. Oh, hello, there you are.
Yeah. Unless, of course, Jaap, do you have anything else to add or no?
I think we addressed most of the questions, or perhaps all of them. So if there are no further questions or issues that people would like to bring up, then I suggest we close the session.
Yeah, then yeah, just briefly, thanks Jaap, thanks Victor for moderating this Feedstock breakout room. We've got quite a good participation, quite a good questions. I think as you pointed out, we covered quite a few topics. And thanks also to IBTC and Bioenergy Europe for helping together with WPA to organize this. Just to point out, the World Bioenergy Association, we've also done 3 previous webinars on agro residues. So along with Bioenergy Europe, we're also exploring this topic quite a lot. So looking at combustion, looking at densification, and of course, torrefaction plays a big part. And I think as pointed out, all the presentations and the recordings will be available on the website, including for the breakout rooms on the website of both Bioenergy Europe and the World Bioenergy Association. So you could get in touch with either of the organizations for more information. So I guess that's basically it from our side as well. I still see that the breakout room for consumers is still on. Technology doesn't seem to be active. So if some of you are interested, you can, if you still have energy, you could still jump onto the consumer breakout room. So basically just click on the breakout room and move to that. But I'll be closing this breakout room at least in a minute or so. So thanks to all again.
Thank you, everyone.
Okay, thank you. Have a nice evening.